maliciously at an application end trying to manipulate that particular web page with an XSS or SQLi, I can block that particular feature. So WAF is very helpful. That is, if I block, if it is possible, I'll block the attacker. If it is not possible, I can stop my feature. That is rest of the 9 features will work except that one until I figure out how to block the attacker. So this gives more control over my application, like various traffics accepted my applications. I can restrict particular traffic according to my needs. So ACLs are created based on customer requirements. Since since it is it depends. Like if it is an e-commerce application we have deployed, then we cannot restrict any of them. We cannot have a login page at the beginning. We need to show all the products offered. So based on the website requirement, we can set the rules or access control list in the web application firewall. And coming to the pricing, the web application firewall service is free, and there are we can set our custom rules in the web application firewall for free. But there are a bunch of packages of offered in the web application firewall. That is the bunch of lists from popular providers like McAfee, etc. So say McAfee did their research and categorized a set of 200 rules, which help a e-commerce website. Okay, if we are what we deploy is e-commerce service, we can pay McAfee and take those lists and apply it in our web application firewall. If 1 or 2 rules are restricting our access, we can edit them and use the rest of them. That is, we have an option to pay and get a bunch of lists rather than creating from the scratch. Get them and just update them to our requirement and use them right away. Later on, we can, if it is not meeting our requirement, we can create our own set of rules, say 50 rules, 100 rules, based on our requirement. But in web application firewall, there is an option to start right away if we pay. Then coming to AWS Shield. This is a security service offered by AWS just to overcome one particular security attack, that is DDoS attack. DDoS is distributed DOS attack. That is an attacker say for this for our website, which is hosted in EC2 instance, which offers to check the offers to buy the train tickets, right? So if an attacker keeps on sending 1,000 requests per second to the web to my website, others the valid users cannot send the request to my website, because if the attacker keep on sending lot of requests per second, then the server's capacity to reply to them or analyze the request is limited. That is, the capability of hardware is always limited. So once it overcomes the computation power of server, then the service becomes overpowered and the service will be down. This is the DOS attack. Distributed DOS attack is an attacker can manipulate 100 machines. For example, he can take over 100 machines and as a zombie, and from these 100 machines, he will send multiple requests at the same time. Okay. If it is DOS attack, it will come from one source from the one IP, one machine, where we can block that IP in firewall or web application firewall. But in distributed DOS attack, it will come from multiple machines, from multiple areas, or we cannot categorize it is from this particular set of machines. So we cannot block it in with our firewall. Even web application firewall cannot block it. So for that, to overcome that, we have AWS Shield, where the existing server capabilities will be increased temporarily. Say, if my web server is capable of computing 100 requests per second, and the attacker is sending 120 requests per second. So temporarily, the 100 requests will be increased to 150 by the AWS Shield, so that it will up to a point compensate for the attack. When the attacker increases from 120 to like 200, say 200, then AWS cannot increase hardware capacity forever. It will increase once. Once it is if it compensates with the DOS attack, AWS will not react to it at that particular point. But if the DDoS attack persists, the buffer level, that is, as an example stated, like say 50 requests per second is the buffer time set for our web service. So it will increase from 100 requests existing capacity to 150. If it is not working, if the attack increases, then the AWS Shield is then the attacker is successful if the attacker increases the capacity. But AWS, but for the customer it is good. Why? Because customer will know the alerts will come up, and to increase the request rate, right, it will take some time. So the customer will have enough time to take countermeasures. That is, say if these DDoS attacks are coming from Iran, all the 100 machines are in Iran. So if a customer have some time, say 10 to 10 minutes, which is provided by AWS Shield by increasing the hardware limit. So this is valuable time. Customer can use it to analyze the traffic and take countermeasures. Say he can block all the traffic from Iran. So this actionable time is provided by AWS Shield. And reports. AWS Shield itself will provide the reports where it will give the combinations, like such as it is all are coming from a Linux machine, or all are coming from one geographical location, or all are coming who are vulnerable to one particular attack. So based on that, we can take countermeasures, or nature of attack can be understood. Because when the alarm hits that our website is vulnerable to DDoS attack, the immediate procedure is to go to the logs and analyze the logs, see how the traffic is, what are the payloads, everything. So we don't have that kind of time. Else the website will be down if the correct measure is not taken. So AWS Shield itself will give the reports where we can see the check the various combinations and take the measures on that. Amazon Inspector. It is to monitor all the resources in AWS environment. That is, say in our use case, we deployed a website, ticket website in an EC2 instance, and with its own database. That is, we have a web server, and a database. These are the resources available. And we configured, say, it might have a gateway, API gateway. Say if we have these three products, we can install Amazon Inspector client agent version in all the resources or the main systems that under our control. We can install them, and this agent, say we install this Amazon Inspector agent in our web server, which is a Linux machine. So we install it. So we once we install it, it is in Amazon Inspector, this agent will generate reports and deliver to us. That is, we don't need to log into the resource or to spend more time to do health checks. So this inspector will give the health checks, downtimes, traffic's available. It will send the report based analysis report every month. And coming to the charges, for how it is charged is, but every agent should be will be charged per month. Say in our case, we are using 3 agents, so per month will be charged for 3 agents for that particular month. Yes, AWS Certification Manager. When we for all regardless for our website, we want to encrypt the traffic. That is, we don't want to operate our website in HTTP. We want to operate in HTTPS. That is, HTTPS is based on HTTP, but it encrypts the traffic from client to server. That is, when I hit on my website, example.com, it will open the web page. So from my browser, I'm sending a request to the web server, and the web server is sending the web content. So that is the flow. In that flow, the request may be is visible in the network. So any attacker can, if he have access to your network, he can see what are the requests you're sending, what is the response coming from that. So if to avoid that, or he can see the passwords, user accounts, etc. To avoid that, HTTPS protocol encrypts the traffic based on the protocol service used SSL, TLS 1.2, 1.3, etc. Based on that, it will encrypt the traffic from the client side, from the browser, and it will that is when you send the request, it will take that request, encrypt it, then send it to server. At the server, the data will be decrypted, and accordingly the response will be encrypted, and it will be decrypted at the client end. So for this, we need to create a certificate that is a combination of public and private key. Public key is given away, and private key is stored at the web server, where private key is the key at the server end, where the data is decrypted and utilized by the server. So for this, for a website to generate a private key, that is charged from the AWS Certificate Manager. But if you already have a private key, that is the certificate, then you can deploy it in our EC2 instance for free using the Certificate Manager. That is, creating the certificate is paid, but using the existing certificate or managing the certificate site to configure for it, those rest of the features are free under Certificate Manager. AWS Artifact. Say for our use case, say I'm booking my train tickets, and it will go to payment page. Okay, so in payment page, it need to take my credit card or debit card information. There is a compliance PCI DSS where all the websites which are accepting card information from the customer, need to follow a set of rules. That is the compliance. Those set of rules are for this particular case are named as PCI DSS compliance. That is a set of rules, say 20, 30 rules need to be followed by all the websites which accept card information from the customers. That is the compliance. Like that, there are various compliance for various activities. These complaints are to support or make our web pages or web services or organization structure more secure. So we need to comply with them, because PCI DSS they have already compiled the rules based on the past history of attacks on how to data protection, etc. They did extensive research and compiled the rules to protect or safeguard a customer's card information. These are the things. Okay. The customer no need to do a research again and come and try to secure the customer information again. No need to reinvent the wheel. It's already there. Customer or developer can simply review them and see if any extra rules need to be implemented, and one or two may be implemented on top of that. That is how that is the way to approach the compliance systems. So AWS Artifact we can require is a service. It's a service where various compliance reports can be downloaded, which are already followed by AWS environment. Say AWS have various features to support web services, databases, S3 buckets, etc. It's AWS have a lot of products and which support a lot of services. So it needs to meet compliances for a lot of them. Okay, say SOC, since network routing is done by AWS, SOC1 and SOC2 needs to be, the other compliances need to be met by AWS. Okay, we need to the customer need to check whether the SOC1 is the compliance is met already. If it is not met, customer will not share, will not configure on AWS network. That means if the particular compliance is met, that means that AWS network is reliable. Else we can assume that it is not reliable up to a point. Okay, so for the customer to trust the existing support system of AWS meets some compliances, and those reports are stored in AWS artifacts. Okay, so say so the customer in our use case, customer is deployed a web application which takes books the train tickets. Okay, for that say it needs to comply with PCI DSS. That is the card information is taken at the application end. So this compliance the customer need to follow. But to trust the AWS network or its services, AWS need to follow its compliance for the customer to trust the network. So these so we can log in, we can go to AWS Artifact and download or request for various compliances which are already adhered by AWS. We can download, we can take them and see how the AWS is meeting the network compliances, etc. And we can review them. We can use it for internal audit or external audit purposes. We can project it as you can show these reports and project that AWS network is reliable. And we can use it as we can use these reports for internal security audit assessments as well. So when you are doing a security assessment, it covers all aspects. Since AWS is it's been compliant with the network requirements, so we can just review them and focus more on application end, since it is already compliant. So that reduces our work. And what are the shared responsibility model we discussed, right? We can use this as a proof that AWS met the requirements to safeguard its services in its responsibility. Summary. So we gone through the use case, like how we can secure our website, which is hosted in cloud environment. And we've gone through the organization structure of the AWS platform, that is using the OUs and members in IAM. And we've gone through this use case to explain various services offered. And we've gone through the services like Cognito, SSO, Inspector, etc. We explained ourselves with our requirements in our use case, and the structure of AWS certifications, like the 4 categories: the fundamental, intermediary, professional, and specialist.